Hello everybody, and welcome to this video series where we will be covering this past paper. This is a grade 12 mathematics paper 1 from November 2016. So just a couple of things about this paper. First of all, I'm not sure how much the syllabus has changed from 2016 to now. Sometimes they add or remove certain concepts. From what I can see, it hasn't changed at all. So everything in this paper should be relevant to candidates writing this year and probably in years to come. It is a 150 mark. It is a 150 marks and it is 3 hours. So often I always say you want to budget 1 mark per minute as your work rate, how quickly you want to work through. What this will do is it should take you about 150 minutes to complete all the questions, or at least to get to the end of the question paper, and that'll leave you with 30 minutes to revise through your work, double check your calculations, and go back to any questions you may have skipped. You should all be familiar with these instructions. It seems like the instructions haven't really changed in the last 8 years. Most of the papers are 12 questions. Graphs onto scale, report values to 2 decimal places where necessary. Obviously write neatly, legibly. These are all things we know. It's good. It is good to know the instructions before you get into the actual exam, so you don't waste time reading these things. You already know what the instructions are, what's expected of you. We are allowed calculators, of course, we know this. One other thing is, do be very familiar with what is on the formula sheet given in the exam, so that you know exactly what formulas you need to know and what formulas you don't need to know, because they're in the back here. Often you actually won't even use most of these formulas. Yeah, some of these formulas are given as extra information. You can do some of the questions and you don't need all of these formulas. You will need some of them. Of course, some formulas should just be known. The equation of a straight line should just be something you know. Finding the gradient should just be something you know. These are literally the same equation. And then, of course, the tangent function is the gradient of another function. Yeah. So just be familiar with all of this. So at the beginning of a new paper, I always spend some time talking about these things. You must be familiar with them. It saves you a lot of time in the exam. It also helps quell the nerves when you know exactly what you're expecting. And it just helps you mentally to be more prepared for the exam. Okay, so now that preamble is over, in this video we will be looking at question number 1. Question number 1 is a whole bunch of different equations, and we got to do a whole bunch of different things. There's an inequality here. We're given equations with exponents, equations with square roots. We have to use the quadratic function here, I'm sure. When you see this little phrase here, you know you're using the quadratic equation, to solve, and you know you're using your calculator, so they tell you, oh, make sure 2 decimal places. A bit of a little hint. Yeah, we got a first derivative here, and we have a simultaneous equation. And question 1 is good for 24 marks. So you probably want to spend anywhere between 25 minutes to 30 minutes maximum on question 1. This is rather straightforward. These are not like really like trickier questions where there's lots of information given or maybe a graph and you kind of have to think out of the box. This is very straightforward. Solve for x and keep it moving. Okay, so with that in mind, let's solve for x. So question 1.1.1, we have x minus 7 equals 0. Okay. So here, I mean, you have two numbers multiplying each other and you're getting a result of 0. So one of them must equal 0. So x equals 0 or x minus 7 equals 0. Therefore, x equals 0 or x equals 7. Yeah. Question 1.1.1 is as simple as that. Okay, question 1.1.2. Let me just get rid of this. Okay. So we have x squared minus 6x plus 2 equals 0. So I'm not even going to try and factorize this. There probably aren't any factors. I'm pretty sure we just have to use the quadratic equation. So without wasting any time, I'm just going to substitute straight into there. So from the equation, we know that x equals negative b plus minus the square root of b squared minus 4ac over 2a. This equation is given in our formula sheet at the end of the question paper, so we don't need to know it by head, luckily. But I mean, you should know it by head. It just saves you time, and it's not that difficult to memorize. So yeah, save yourself the time of trying to like flip through the question paper and then figure out the formula. If you're familiar with it and you've practiced enough, you should know it by head, and it saves you a bit of time. So negative b would just be 6 plus minus the root of negative 6 squared would just be 36 minus 4. A is 1, c is 2, so I'll just put in 2 over 2. Yeah. Okay. And then we can do some work here. So 4 times 2 is 8. 36 minus 8 is 28. So we have x equals 6 root 28 over 2. And if we work this out, our two values of x will be 0.35 or 5.65. Okay. Two decimal places as stated in the question. So couple of things. I mean, I've just realized that you can solve this equation without using the quadratic formula. Honestly, the quadratic formula is just quicker and cleaner. Just use it. But you can also solve it by completing the square. Luckily, you don't have to complete the square. Like in what I've seen in most of these question papers is you don't have to know how to complete the square. Like there will often be like a different avenue you can go down to solve an equation, and they don't give you questions where they specifically ask you to complete the square or where that's the only method you can use. So you don't need to know it as far as I can see. It's probably good to just know it, to have it in the back of your toolbox, so that if the situation does arise and that's the only way to answer a question, you can do it. But completing the square is done in a couple more steps. It's not that difficult to do. So if you're comfortable, definitely do it. Just know it at least. But from what I've seen, I haven't yet seen a question that forces you to do completing the square. So maybe you don't have to know it. But yeah, that often is the way to go when you can't factorize a quadratic function directly. You either use the quadratic formula or you complete the square. So what would be a situation where you would only have to complete the square? Maybe if they want you to like rewrite the quadratic formula in a certain way and you don't have enough information to use the quadratic formula to solve for x. So you're trying to rewrite it, yeah, maybe do some algebra on it or something to get it into a certain form. That's when you would only be able to complete the square. That's the only method that would work. But I haven't seen questions like that yet, so yeah. Wouldn't worry about it too much, but I just thought something worth mentioning. Anyways, let's carry on to question 1.1.3. Okay, so we have the square root of x minus 1 plus 1 equals x. Okay. Now, yeah, what I would say is try to isolate the square root first. So have it on its own and then take the squares on both sides of the equation. Because if you take the square now, yeah, you're going to get a pretty complicated expression here. It's not going to simplify nicely. So definitely, let's first take the one the other side. So we'll have, and then we can square both sides. And of course, when we square both sides, technically we're just left with x minus 1 this side. And then this equals, if we expand this, we'll get x squared minus 2x plus 1. Then isolating all the terms on one side and equating to 0, we'll get x squared minus 3x plus 2 equals 0. Factors of this, so our coefficient of x squared is 1, so I think we can use the simple method. So numbers that multiply to give 2 and add, so negative 2 and negative 1, yeah. So x minus 2, x minus 1. So x equals 2 or x equals 1. Yeah. And now, tricky part. Go back to the beginning of your equation and recall that we had a square root. And also, whilst at this point you should be aware that complex numbers do exist, i.e. Imaginary numbers, numbers like I, which equal the square root of negative 1. This is something that exists. It's not really part of our syllabus, but I think we should be by now be aware of such things. But anyways, in this syllabus we cannot take the square root of a negative number. So yeah, or at least especially yeah. So we need to make sure that our values of x will give us something, basically won't give us a negative number under our square root sign. And the thing is, I mean, you can, although technically I don't know what the square root of 0 is. Yeah, I don't know. Some people would argue that this doesn't exist. I think for us it's fine. So both 2 and 1 are valid inputs for our function. So yeah. But if we had a number like maybe somehow we got like -1, then we say -1 minus 1, we get -2. Square root of -2, we can't do that. Okay, it won't work here. But for +1 and +2, it's fine. So just something to check, because students often forget this and then you lose a mark on your final answer because you didn't say that one of the values of x is not valid for our equation. Okay, let us move on. So we have some exponents. Okay, so 3, oops, let me change back to my pen. 3 to the power x plus 3 minus 3 to the power x plus 2. Did I skip something? Okay. Okay. Sorry for that. Okay, equals 486. Yeah. Now, yeah, I mean, there are many ways of doing this, and what I've seen is that logarithms are not really part of the syllabus yet, but we can definitely use logarithms to do this. I won't, because I don't think everyone gets taught this. Some people do, some people don't. You don't have to know logarithms, but logarithms definitely the way to go. It's the easiest way to solve these types of questions where you have unknown values in your exponents. But anyways, what we will do is we will just play we will use some laws of powers in order to manipulate this equation to solve it. Okay. What's nice is they've given us everything in base 3. Yeah, so one way of doing this as well is, I mean, you can figure out if there's some power, that we can raise 3 to, maybe not call it x, let's say some power z, that'll give us this number back. And the way you would check this, I mean, just for fun, is you would just type in your calculator log base 3 to get 486. And I wonder if it's a whole number. If it's a whole number, that would be really cool. Unfortunately, it's not a whole number. It's like 5.6309. So if we raise 3 to the power of 5.6309, we will get 486. So this is really cool, because what this means is if everything is in base 3, then we can just eliminate the 3's, essentially. Well, not really, because of this negative sign, but then we could just equate the exponents to each other. But I digress. After just saying we won't do logarithms, I go ahead and do logarithms. But logarithms just make this so much easier. Okay, but anyways, we're gonna be doing something similar to what I just did. playing games with the rules of powers. So the first thing is to realize that we have 3x in both situations, 3 to the power x. And you must remember when you multiply two powers, so 3 to the power x multiplied by 3 to the power 2, it gives you the same thing as 3 to the power x plus 2, yeah? So we can break these down and factor out a common factor of 3 to the power x, yeah? So, okay. Okay, bear with me. So what we're going to do is we're going to factor out 3 to the power x, and we're going to be left with 3 to the power 3 minus 3 to the power 2 equals 486. Okay, that's step 1. Now we can solve this. 3 to the power 3 is 3 times 3, 9 times 3 is 27. 27 minus 3 to the power 2 is that's 9, so you have 18, yeah? Then you can say 486 divided by 18, I believe that should be about 27. So you get 3 to the power x equals 27. Now 27, you should realize you can now do what I tried to do earlier. You can write 27 to some power, and we know that you can use your calculator. So we're trying to write it to the power base 3, so we can find like the cube root of 27. I believe it's 3, yeah? So 3 to the power 3 should give us 27. Okay, so we can just rewrite 27 in base 3, which is 3 to the power 3. And from this you can see that, well, x just equals 3, yeah? You can see that. So this is one way of doing it. Sometimes it's not very easy to like get everything in terms of base 3 and then match the exponents and then evaluate x, and that's where like logarithms come into play. But since I don't think we cover logarithms in the syllabus, yeah, they shouldn't give us a question that we can't do using this method. We should always be able to use that method. Okay, question 1.2. So they give us some function f of x. It's a quadratic function, and they say solve for x if f of x equals 0. Okay, so our coefficient of x, okay, so what numbers can multiply to give -4? I think 4 and -1, yeah? Yeah. That's the answer, yeah? Okay. Very straightforward. Solve for x if f of x is less than 0. So if f of x is negative, Okay. So we should see that the general shape is something like this. We have negative 4 here and 1, and this is f of x, yeah. So when f of x is less than 0, that is this side. So basically, what are the values of what are the x values? Okay, so we can do this a couple ways. I mean, it's pretty easy to see what the values are, but yeah, you can do it legitimately, but you can see that that the values would simply be negative 4. X is greater than negative 4 but less than 1. Yeah, you basically just swap over to inequalities. I mean, they don't actually give you marks for any working because you've done the work here. You just need to realize that you have to rewrite your answer or something like that with the inequality. It's pretty much the same thing. Because we're saying when f of x is less than 0, so basically when the function is negative in terms of the domain, so in terms of y, which is only this shaded region at the bottom when it's below the x-axis. It's above the x-axis, f of x is actually greater than 0. So remember, f of x refers to like the domain, the y values. F is the y values. So it's like the same as writing this equation as f of x equals y equals the actual equation. So yeah. So very simple. Okay, good for 2 marks. Let's carry on to 1.2.3. Determine the values of x for which f prime of x is greater or equal to 0. Okay, so the first thing is to determine f prime of x. So we have 2x plus 3. That's f prime of x. And then greater or equal to 0. So and then solve for x. So what do we have here? So it's simple inequality. Take the 3 the other side. Yeah. But yeah. Yeah. Okay, what else can we say? So f prime of x is greater than 0 and f is increasing. The turning point occurs at that. Yeah, I mean, this is good enough for the 2 marks. You're done. You can actually also get to this answer from this information, but I think it's just easier to do it this way. Okay, let's get into the last question of question 1. So they give us a simultaneous equation. So x equals 2y and x squared minus 5xy equals negative 24. So solve. Okay, so I guess we'll just use substitution, yeah? So we have 2y squared minus 5 2y y equals negative 24. I mean, there's many ways to solve simultaneous equations, but they've given us this simple equation, so we'll just substitute it in. So here we get 4y squared minus 10, not 20, 10y squared equals negative 24. Can actually just factor out like 2y squared, yeah? And then we're left with 2 minus 5 equals negative 24. So this is negative 3. Divide negative 3 both sides. We get 8, 4, is plus minus 2, yeah? Okay, so then y is plus minus 2, so x would be, so if y is plus 2, x is 4, and if y is minus 2, x is minus 4. Okay, done. I guess the tricky thing is just to realize that when you take the square root here, it's plus minus, yeah, so y is plus or minus 2, not just positive 2. So you have 4 answers, 2 answers for y, 2 answers for x. And yeah, that concludes question 1. Thank you.